Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwane, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Remember, grade 12, our WhatsApp number is 079 454 9535. You are more than welcome to send your clarity-seeking questions to that particular number or share any alternative solutions that you wish to share with the rest of the group. Okay, today we'll be looking at the analytical geometry, of which at the end of this particular lesson, you must be able to determine the distance, length between 2 points, and then you must be able to determine the midpoint between 2 points, and then you must be able also to determine the gradient of a line segment connecting 2 points, and then also to determine the equation of a straight line passing through 2 points, and then also to determine the equation of a straight line passing through 1 point and parallel or perpendicular to another line. Lastly, you must be able to determine the inclination theta of a line with the aid of the gradient, where theta lies between 0 degrees and 180. That means grade 12, this inclination angle will lie only between 2 quadrants, which is quadrant 1 and 2. As is being indicated that it must be between 0 degrees and 180 degrees. Now we have specific formulae that we are applying under analytical geometry, and then these formulae, grade 12, you will find them on your formula sheet at the back of your question paper. Please double check before you note down any formula that it is correctly copied from the formula sheet. For the distance formula, or where you are calculating a length, this is the formula that we are applying, which indicates the distance is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And then that means grade 12, for this case, you must be given 2 points of which you will be applying. Hence, we are having the x1, x2, y1, and y2. And then now, for the coordinates of the midpoint is a middle point between 2 points again. So you need 2 points in order to calculate the midpoint. So the formula for that, remember this will be in coordinate form because it's a point. You'll be having an x and y value. And then now to calculate this, we start with the value for the x value and then followed by y. It is always x and y in the correct coordinate form. So now to calculate this, we use the formula x2 plus x1 over 2. Be careful, grade 12, you are not subtracting as in a distance formula. On this one, you are adding. And then now for the y value, it's y2 plus y1 over 2. Also be careful, you are adding, not subtracting as in a distance formula there. And then now to find the equation of a straight line, you are having 2 options. You either use the original equation y equal to mx plus c, or you can alternatively use y minus y1 equals to m into x minus x1. Remember, you must have a gradient and a point in order to be able to find the equation of a straight line. Moving on to the gradient of a line. A gradient will either be an average gradient or the gradient of a line. It must be between 2 points. To calculate the gradient, you also need 2 points because you are calculating y2 minus y1 over the x2 minus x1. So the gradient is equal to the change in y over the change in x between 2 points. And then we have conditions now. If you are having line AB being parallel to line CD, therefore you can conclude that the gradient of AB is equal to the gradient of line CD, only with the condition where the 2 lines are parallel. And then second condition is where you are having 2 lines being perpendicular now. if line EF is perpendicular to line GH, then the gradient of line EF multiplied by the gradient of GH is equal to -1. That means the product of the gradient of the two lines, of which the lines are perpendicular, it will be equal to -1. Product is the answer that we get when we are multiplying. Hence, we are saying the product will be -1. Angle of inclination. An angle of inclination is calculated using the equation tan theta is equal to m, of which m is the gradient of the line we are referring to. And then that means it also indicates the slope or a gradient of a line. Inclination is the slope or the gradient of a line. All right, and then now it lies between 0 and 180. This is supposed to be 180. Grade 12, please rectify that accordingly. The theta inclination angle lies between 0 and 180. That means if we are inclining, we refer to quadrant 1 and quadrant 2 of your 4 quadrants. Okay, and then it is measured anti-clockwise. Anti-clockwise, it means we start from 0, moving to your left-hand side, grade 12. That is anti-clockwise. Remember, clockwise, we are following the clock to the right, but if it's anti-clockwise, it's from the x-axis, 0 degrees to the left-hand side, towards your second quadrant. And then now, this angle is between a line and the positive x-axis. Your inclination angle will be found between your x-axis and your line, the straight line that we are referring to, of which you are going to use the gradient of the line. It's either in quadrant 1 if it is less than 90, or if your gradient is positive. And then as the line will be increasing. Remember now, grade 12, if you are having an inclination in quadrant 1, that means the angle will be less than 90, right? And then according to this line is an increasing line. Remember from your functions that if the line is increasing, that means the gradient is positive. That means when you are calculating your inclination and then you find out this gradient here is positive, that simply means your angle will be less than 90 degrees. I hope that is clear, grade 12. The second condition is where you are having an inclination slanting to the second quadrant. That means, remember, we measure from the x-axis to the straight line. So if you look at the line is decreasing. So the minute the line is decreasing, that means the gradient is negative. So that means you'll check if your gradient is negative there. That means now your angle will be greater than 90 but less than 180. It will be in quadrant 2. I hope that is clear. We will elaborate more as we continue on our activities. And then now here we have our first activity. The diagram shows triangle DEF. This is the triangle we are referring to, DEF, with vertices D equal to coordinates -4 and 8. And then we have point E with coordinates 4 and -4. And then we have point F with coordinate -2 and -8. And we have the angle of inclination of DE. And then the angle of inclination with the positive axis is alpha, as indicated there on the diagram. And then we are also given that angle E is equal to 90 degrees, grade 12, as indicated on our diagram there. That small cap there is telling us that that angle is equal to 90 degrees. So after going through the whole given information, checking that everything is indicated on the diagram, it's only then that we can look at the question. So the first question says that determine the gradient of DE. So we are directed by that DE, that we need coordinates of D, of which is -4 and 8, and then we also need coordinates of E, of which is 4 and -4. And then now if we are looking at the gradient, remember the formula is from your formula sheet. M is equal to y2 minus y1 over the x2 minus x1. And then now grade 12, you can name maybe D being the family one, it will be x1, y1. And then E being the second one, it will be x2 and the y2 there. Then from there you can now substitute into your formula. What is y2? Minus 4. And then minus from the formula there. And then what is y1? 8 all over x2 4 minus, and then the x1 is minus 4. Can you see that it's a minus from the formula and then the minus from our x1 value there? And then now you put everything into your calculator, grade 12, straight to the answer. This will be minus 3 over 2 in a simplified fraction there. And then the allocation of marks there is 2 marks. Therefore, the first mark will be correct substitution into the correct gradient formula. And then the second one will be for your final answer. So the most commonly mistake done by learners is that they swap the formula around. You'll find that they write x2 on top and the y2 on the denominator. If that is the case, grade 12, whatever you are doing there, you will get 0 out of 2. Because why? The formula is incorrect. Incorrect formula, 0 mark. So let's ensure that we copy our formulas correct from the formula sheet. That is the gradient of DE. And then now continuing, we are still in the same diagram with the same given information. Now we need to determine the size of angle alpha. Remember, we have calculated that the gradient of DE is equal to minus 3 over 2. As you are calculating, relate your solutions to your diagram, whether are they correct or what, according to the prediction on the diagram. Now, when you look at line DE, you can see that is a decreasing function. Okay, this line here, it's a decreasing function. So if it is decreasing, that means we are expecting a gradient that is negative. Now we relate this interpretation with the answer. Is it negative? Yes, that means our gradient calculation is correct versus the diagram. Okay, now we need to address the question now. Determine the size of angle alpha. Now if we look at alpha now, we have discussed this earlier on, that if the gradient is negative, that means your angle will be between 90 and 180, is more than 90 degrees. And remember, if we are in this quadrant, grade 12, in quadrant 2, your reduction here will be 180 plus, when you apply your trigonometry now relating to this topic. Okay, right now, let's do the inclination calculation. We know that the formula will be tan. Our angle is alpha. Now you can't use theta because the given angle here is alpha. So we talk with tan alpha equal to the gradient of which line? The line that this angle is rotating to, of which is line DE. So it will be the gradient of DE there. And then now remember, we are looking for tan alpha equals to, gradient is minus 3 over 2. And then this negative here, it is showing us that we are going to solve in quadrant 2. But before we do that, we need to look for the reference angle of our alpha here. That will be calculated using the arctan of 3 over 2. We are neglecting this negative grade 12 because it's showing that we are working in quadrant 2. And then now we will get your reference angle. Our reference angle will be 56,3 degrees there. Remember, this is a reference, it's not yet our solution, because our solution must be greater than 90 degrees because the gradient is negative. Now to find the real value of alpha now, we are going to take this reduction now. It's 180 minus, sorry, not plus there. And then now this will be reduction in quadrant 2 is 180 degrees minus the reference angle, which is 56.3 degrees. And then this is giving us an angle which is 123.7 degrees, grade 12. So be careful. If your gradient is negative, calculating inclination, your value must be greater than 90 but less than 180. And then now let's look at the allocation of marks. We are having 3 marks there. The first mark will be the substitution of the gradient into the correct inclination formula. And then the second mark will be for the reference angle of 56.3. And then lastly will be for the final correct value of your inclination angle, of which is 123.7 in this case. So that is how basically you calculate your inclination angle, grade 12. Moving on to the next activity. We are still on the same diagram. They say determine whether the line parallel to DE passing through F also passes through the point -10 and 5. Okay, we are testing that this line here, this one that is parallel to the DE line, which is passing through F there, is this line also passing through the point -10 and 5. Now, grade 12, you need to analyze this question. Determine where the line is parallel. The minute you have parallel lines, that means the gradient of the two lines must be positive. Now, if they are saying to us, let's check, is this line passing through F also passes through -10 and 5? If that is the case, that means the gradient of the line that is passing through -2 and 8, because it's passing through F, those are the coordinates of F, -2, -8. And then they say this line is also passing through -10 and 5. And they say this line, is it parallel to the line DE? And is it also passing through -10 and 5? If it is passing through -10 and 5 and is parallel, that means the gradient must be the same as the gradient of DE. You still remember that the gradient of DE we have already calculated as being -3/2. If we can calculate the gradient of this line and get a -3/2, therefore the line is passing through that point and is also parallel to DE. Let's see. Now we are calculating M of the line. And then this line, gradient y2 minus y1 over x2 minus x1. This will be our x1, y1, x2, y2. And then what is y2? 5 minus what is y1, y1 minus 8 all over the x2 is -10 minus the x1 is -2. Perfect substitution. And then everything into your calculator, grade 12, no need for partial simplification. And then if we look at the gradient of this line, this is giving us 13/8. It's a negative gradient, 13/8 there. Now we are comparing this with the gradient that we have there. Do we have the same gradient? No. That means if it is not the same gradient, this point does not lie on this parallel line here. Because if it lies on this parallel line, it must give us the same gradient. Therefore, the M of a line is not equal to the M of DE. Therefore, point -10 and 5 does not pass through F. Okay, thank you, grade 12. I hope we are together in this one. It's level 3 questions. It's not straight. You have to analyze and find out what is going on. So 1 mark will be substitution there for the gradient of that line, and then for the conclusion you are having your extra 2 marks for that. And then moving on to 1.4, we are still on the same activity there. Grade 12, now we need to calculate the area of triangle DEF, the area of triangle DEF. This is our triangle that we are referring to. And then this triangle, can you see that it's a right angle triangle because it is having a 90 degrees there. This is your grade 10 content, grade 12, where you are calculating the area of a triangle. So now I am giving you 3 minutes to try to calculate this gradient on your own, just to remind yourself with the grade 10 content, and then we will reflect back and see how far did you go with this particular question. Your 3 minutes starts now. Okay, grade 12, let's see how far did it go. Remember our WhatsApp number 079-454-9535. You are more than welcome to send your clarity seeking question to that particular number, or any alternative solution you like to share with us, grade 12. Okay, let's see now. We are calculating the area of triangle DEF. Do you still remember the formula, grade 12? To calculate the area of a triangle, you need half base times the perpendicular height of our triangle. And then in this case, what is our base? Our base is FE here. And then the perpendicular height will be DE there. So now you cannot calculate unless you have the distance for those lines, okay? So now you need to start by calculating the distance of FE. So we are going to calculate EF is equal to the square root of, remember it's x2 minus x1, therefore it will be 4 plus 2 squared plus the y2 minus, that is minus 4, plus 8 squared. And then you put this into your calculator, grade 12, we end up with 4 square root 13 for the distance of EF is 2 square root 13 for EF. And then now let's calculate the distance of ED now. To calculate the ED is the square root of, let's check now, the x2 we are having 4 plus x1, because it's minus 4, that is why we are saying plus 4 there, and then squared, and then with the y2 we are having minus 4, and then it will be minus 8, and then this will be squared also, and then everything into your calculator inside the square root sign, grade 12, we end up with 4 square root 13 for the distance of ED. Now now we have the distance for EF, which is 2 square root 13, and then we have the distance for ED, which is 4 square root 13, and then we can now calculate the area, of which is half of the base. What is base? Base is EF multiply perpendicular height is DE, or ED, it's fine. And then this is half. What is the EF distance? Is 2 square root of 13, and then into 4 square root of 13 for DE. And then straight into your calculator, grade 12, to the answer. Your final answer will be 52. And then because this is an area identity, it will be unit squared there. Okay, that is the area of that particular triangle. And then this is allocated 5 marks. The first mark will be for the first distance there, and then second for the second distance, and then third it will be for the substitution, okay, for the correct formula of the area of a triangle, and then the substitution, correct substitution into the correct formula, and then finally it will be for your answer, grade 12. That is the 5 marks allocation for that particular question. I hope you got it correct, grade 12. We are just reviving our grade 10 knowledge around the areas. Now let's move on to the next activity now, activity 2. The second question now. In the diagram, triangle RST with vertices R is 4 and 3, their coordinates, S is 1 and 0, as you can see it lies on the x-axis there. And then we have T, RST, T is 5 and 4 there, and 4, 5 and minus 4. As given, the angle of inclination of RS is with the positive x-axis is theta. Therefore, we are talking to our theta angle there. And then determine the gradient of RS. Look at line RS. This is an increasing line. So if it is increasing, we are predicting a gradient that is what? Positive, grade 12s. So before we calculate, we automatically know that we are expecting a gradient that is positive. And then in order to calculate gradient, you need 2 coordinates. Which ones are we relying on? The R and S. So we need the coordinate of R being 4 and 3, and the coordinate of S being 1 and 0 there. Okay, and then now let's start calculating. We are looking for the gradient of RS, and then this is y2 minus y1 over the x2 minus x1, and then this is family 1, x1, y1, next family x2 and the y2. And then let's now substitute, grade 12. What is our y2? 0 minus y1 3 over x2 1 minus x1 4, and then into our calculators straight to the answer, grade 12. Our answer will be a positive 1. Can you see now? This is satisfying the condition that we predicted, that the gradient must be positive. So our gradient is positive. Allocation is 2 marks. Therefore, it will be 1 mark for the substitution and 1 mark for the answer. And then move on to the next activity number 2. And then in this case, we are still using the same diagram. Remember, this is T here, not R. This is T. And then now they say determine the value of theta. Look at theta, grade 12. And the gradient, you still remember the gradient of this line is equal to 1. It's a positive gradient. And then now we have indicated earlier on that if the gradient is positive, that means the inclination angle will be less than 90 degrees. So now the slanting of a line is also satisfying that, as you can see that this angle is less than the 90 degrees. So now after analyzing that, we can now calculate grade 12 and then determine the value of theta. Do you still remember the formula of inclination is tan of theta equal to the gradient. Is the gradient of which line now? Remember, from the x-axis to the line we are referring to is line RS. So is the tan of theta equal to the gradient of RS, of which we have calculated as being 1. And then now theta will be equal to the tan to this side will be arctan of 1 into our calculator grade 12. The theta angle will be equals to 45 degrees. I hope we are still together, grade 12. This is 45 degrees. It is less than 90. We stop there. We don't go 180 minus because the gradient is positive. If it was negative, we will be regarding this as a reference, continuing to 180 minus the theta. So our answer is theta equals to 45. So the first mark will be for the tan theta equals to 1, and then for the simplifying, and then the third one for the angle there. Therefore, this is worth 3 marks, grade 12. Moving on, and then with 2.3 there, we are still in the same diagram, and remember this is T, and then we are having a gradient that you have calculated, which is 1, and then we have calculated that theta is 45 degrees. It is very important, grade 12, as you are calculating any new information, put it in the diagram. It might assist you to answer the questions that follow. All right, and then from here now they say calculate the length of RT in simplified said form. Okay, the length of RT, let's go to the diagram. We are looking at the length of RT. That means it's from here to that point, and then in a simplified said form. So the minute they say in the simplified said form, grade 12, they are simply telling you that leave your answer in a said form with the square root or with the root sign on it. You do not have to press your SD button and take it to decimal. We do not want decimal answers on your solution because they said leave your answer in a said form. So grade 12, before I can go through this one, and let's see, can you answer, calculate a length? We've been doing this on the previous activity. I want you now to do this independently on your own. I am giving you 3 minutes to calculate that length, and I'm expecting you to be 100% correct because you are doing this for the second time now, grade 12. Let's see how far can you go, grade 12. Your 3 minutes starts now. Okay, grade 12, thank you very much. Let's see how far did you go also with this one. Remember our WhatsApp number 079-454-9535. Grade 12, please send your alternative solutions or any clarity seeking question to that particular number. You are more than welcome to do so. Right, we are looking at the calculation of the length RT in a simplified set form. It is very important, grade 12, to take out your coordinate out of the given information there, because you'll end up selecting wrong coordinates, grade 12. So now let's bring it closer. The coordinates of R is 4 and 3, and the coordinates of T is 5 and -4. And then now we are calculating the length. You look into your formula sheet. The formula is there for the distance, because length and distance is the same thing. So now we are calculating the distance RT. So we'll be having RT is equal to, the formula states that you are looking at the x2 minus x1 squared plus y2 minus y1 all squared. This formula is available on your formula sheet. The only difference is that it is written D there to show it's a distance. So yours must be specific that you are calculating the distance of RT there. And then now let's name our families. Family 1 is x1, y1, and then with the x2, y2 there. And then let's substitute grade 12 into the correct formula. And then now we are having x2 being 5 minus x1 4. And then this is all squared plus the y2 is -4 minus the y1, which is 3, and then everything squared. And then straight into your calculator, grade 12. Avoid partial simplification, because it's where we encounter a lot of mistakes as learners are trying to simplify that. So after your substitution, put everything into your calculator with the square root sign, and then now we end up with the answer 5 square root 2. I hope you managed to get that particular answer, grade 12. And then the first mark now, since it is allocated 2 marks there, the first mark will be your correct substitution into the correct formula. The substitution must be into a correct distance formula. And then the last mark will be for simplification. So this is worth 2 marks. Can you see, grade 12, your partial simplification in between there? No allocation of marks. We are only interested on your substitution and that your answer is correctly noted there. So we leave this answer in a simple set form. You can't put this in your calculator and check how many decimals do we have, 5 something. No, because the question indicated clearly that you must leave your answer in a simple set form. Therefore, grade 12, that is how far you must go with that particular question. Right, on question 2.4, we are still on the same diagram. Remember, this is T. Okay, determine the coordinates of the midpoint. Midpoint is a middle point between S and T. Calculate the coordinates of the middle point between S and T. Do you still remember our tip? Is that take out the coordinates of ST from the given information. So what is S coordinate? Is 1 and 0. To avoid mistake, grade 12, this will assist you. And then T is 5 and -4. Do you still remember the coordinate formula? We are looking at the midpoint of ST, of which will be the x2 plus x1. Be careful, grade 12, it must be a plus for this formula. And the y2 plus y1. Most of the learners encounter mistakes here by writing as x2 minus x1, confusing this with the distance formula. This one is a plus, okay? And then now we can now name our family x1, y1, and then this is the x2 and the y2 family. From that one, we can now substitute. What is our x2? 5 plus the x1 is 1 all over 2, and the y2 minus 4 plus y1, which is 0, and everything over 2. And then 5 plus 1 is giving us 6 over 2, and then minus 4 plus 0 is minus 4 over 2, and then the final coordinate now of ST, it will be 6 over 2, which is 3, value of x, and the value of y minus 4 over 2, which is a minus 2. And then therefore those are the coordinates of the midpoint of ST. ST is this line here, ST, and then the middle point must be somewhere there. And then now let's check. Now we are saying the coordinates are 3 and minus 2, where x is positive. Yes, that is true. And the y value is negative. That is also true, grade 12. So after calculating your values, please verify with the diagram whether are those values suitable for the diagram. They fit in very well into your diagram or not. Okay, so now let's look at the mark allocation. This is 2 marks. It will be the first mark for the substitution into the correct midpoint formula, and then the last mark will be for your correct coordinate of that particular point. Now with the 2.5, a line is drawn parallel to RS. Remember, this is T here. A line is drawn parallel to RS. There's a line drawn parallel to that one. And then through the midpoint, remember you have calculated the midpoint above, and with the coordinate of the midpoint is minus 3, is 3 and minus 2, sorry, grade 12, 3 and minus 2 and minus 2, and they say now a line is drawn parallel to RS, and then it is passing through the midpoint of ST. So now this line is passing through here, and then it is parallel to RS, and then determine the equation of the line that is parallel to RS, and then this line is passing through the midpoint of ST in the form y is equal to. Now grade 12, remember this is a straight line. A straight line, we are using the original, which is y equal to mx plus c, or you can use alternatively y minus y1 equal to m into x minus x1. You are also welcome to use that particular equation. Now to determine the equation of a straight line, you need a gradient and a point, right? With the point we are covered because this line is passing through that. So now we are having a point which is 3 and minus 2 happy. So we need a gradient of that particular line. But according to our knowledge, we know that if lines are parallel, therefore their gradients are the same. Okay, so now we have calculated, remember, the gradient of SR on our previous activity, that the gradient of SR is equal to 1. So now if these lines are parallel, that means therefore also the gradient of the line will be equal to 1. Why? The two lines are parallel. Parallel lines, they have exactly the same gradient. Happy? We have a gradient of that line and the point. Now we can find the equation of that particular line. This will serve as our xy in this formula. So our y is minus 2. Our gradient is 1. The value of x is 3 plus c. In order to have an equation, we need to calculate the value of c. That means the aim here is to find the value of c. Then it's minus 2. 1 times 3 is 3 plus c. And then we transpose 3 to this side. It will be minus 3 minus 2, which is minus 5. That is the value of c. And then now we want to finalize the equation. We take the original mx plus c. we are going to leave y and x, substitute m and c. Then the equation will be y equal to gradient is 1, remember, x, and then c is minus 5. Therefore, that is the equation for that line. Y equal to x minus 5 is the equation of that parallel line. So now let's see the learner who decided to use another equation, that one of y minus y1 into m equal to m into x minus x1. So now this will serve as the x1 and the y1, the coordinate that is given to you. And this will be y minus 2, it will be plus 2 there. Negative by negative is a positive. And the gradient is the same, that one that we have just predicted there as being 1. And then x and the x1 will be minus x1, which is 3. And then you have y plus 2 equal to, distributing 1 here will be 1 times xx, 1 times minus 3 is minus 3. And then we have y, we are transposing 2 to minus 3 there. Then this will be equal to x. 2 becomes negative 2. Minus 2 minus 3 is minus 5. Can you see grade 12? We end up with exactly the same equation of that particular straight line. And then let's look at the mark allocation. Then it is allocated 3 marks. 1 mark is for finding the correct gradient, that line will have the same gradient as SR since the lines are parallel. So the first mark will be for the gradient of the line being 1. The second mark will be for substitution of the gradient and the coordinate into the correct formula, that is that condition. Or when you are using this formula, it will be at that point. Lastly, it will be for the correct formula now with the correct value of CB minus 5. Your formula at any level, we either using one of the equations there. So this is how we allocate our 3 marks. For the gradient, for the substitution of the gradient and a point, and for the final equation of that particular line. Okay. And then moving on, grade 12s, we are moving to the next activity now. That is activity number 3. In the activity number 3, they say in the diagram, PQRS is a parallelogram. The minute you see the word parallelogram, you must know all the properties of your polygons, grade 12. Being your quadrilaterals, you must know that the properties of a square, the properties of a rhombus, properties of a kite, properties of a parallelogram, and so forth. So the minute you see the word parallelogram, it must come automatically, the properties of the parallelogram, that opposite sides are equal and parallel. Okay, that is your parallelogram. So now by just indicating to us this is a parallelogram, we know that the opposite sides are parallel. You can indicate the information on the diagram, and they are also equal. And the opposite angles are equal. You know those properties, grade 12. You must automatically know your properties, grade 12. That is very important. So now this whole information comes only from this word parallelogram. Okay. And then now let's go to the statement again. In the diagram, PQRS is a parallelogram with vertices. P is minus 2 and 2. Let's see, are we correct on the diagram? P minus 2 and 2, yes. Q 0 and minus 4. Q is 0 and minus 4. And if you look at this, if X is 0 and Y minus 4, can you see this is the intercept there? This is cutting on the Y axis. Okay, that point cuts on the Y axis. And then R is 6 and minus 2, yes. And then S is 4 and M, we don't have the value of Y there. And then they say E is the midpoint of PQ. Yes, we have point E there. which is the midpoint of P and Q. The middle point, that means this is equal. This piece is equal to that one. Okay. Now, the angle formed by PR and the positive x-axis is theta. So we are having an angle between the x-axis there to that point. Therefore, if it is between the x-axis and the line grade 12, what do we call that? An angle of inclination. That means that theta is an inclination angle. We can predict, since the line is a decreasing one, therefore the gradient is negative. So we are expecting an inclination value that is between 90 and 180. Can you see grade 12? This is now becoming more clearer. It can be predicted before your calculations, the expected value of inclination. Now, in this case, anyway, we are expected to determine the gradient of PR. Let's look at PR line. So this is a line that is passing there. It's a diagonal of one of the diagonals of this parallelogram. So PR, look at PR now. We are looking at the gradient. Is it an increasing or a decreasing line? PR is a decreasing line. From left to right, it is going down. Therefore, it's a decreasing line. So if it's a decreasing line, that means we are expecting a gradient that is negative for this calculation. Okay, we have analyzed, we know the expectations, grade 12. Now we are looking at the gradient of PR. Remember, the tip is that take out the coordinate that you are going to use to avoid mistakes, because now you have plenty of them there. You will end up selecting the wrong ones. So now we need P, which is minus 2 and 2. We need the R, which is 6 and minus 2. So we are looking at the gradient of PR, and then we are using the same formula, y2 minus y1 over x2 minus x1, and then now family 1 x1 y1, family 2 x2 y2 there. Substitute into the gradient formula. What is y2? Minus 2 minus y1, 2, and then over x2 is 6 minus 2 from that one. It's a minus from the formula, and the negative 2 from the x1 there. Remember, do not confuse the two. Grade 12 is two negatives, one for minus of the formula and the negative 2 from the x1 value there. And then now straight into your calculator to the answer, grade 12. This will give us a negative 1 over 2. That is the gradient. Is it correct? Yes, we were predicting a negative gradient, and our gradient is negative. The happy grade 12s, this is correlating perfectly so with what we have predicted for the gradient of PR. And the allocation of marks, this is 2 marks. It will be 1 for the substitution, and then another mark for your gradient there. So this is worth 2 marks, grade 12s. Moving on to the next question. 3.2, determine theta, of which is the angle of inclination. We have already discussed this, grade 12, that if you look at that inclination angle, it is automatically greater than 90 degrees. Can you see that? And then that means it's the one that is having 180 minus. So the gradient of the line is also negative. We are depending on the M of PR because inclination and stops at that line. Okay, so M of PR, remember we have just calculated as being minus a half. Yes. Now if it is negative, that means our inclination will be 180 minus the reference angle. That is the expected inclination calculation. Okay, and then now let's start now. We are looking at the angle of inclination of PR. So the formula for the angle of inclination is tan of theta equal to the gradient of the line where theta lie, which is PR, inclination with the gradient of PR, and then that is the tan of theta equal to the gradient of PR, of which is minus a half. And then now we look for the reference angle of theta, because now our theta lies in quadrant 2. So that will be arctan. I'm excluding a negative because it indicates the second quadrant, grade 12. And then now that is the arctan of half. So now if you look at that reference angle, it is giving us 26,57 to the second decimal place. But this is not yet our solution because this value now is less than 90, whereas we are expecting an angle that is greater than 90. So now we are going to look at the actual theta value, of which will be in quadrant 2. Reduction in quadrant 2 is 180 minus the reference angle 26,57 from the above here. And then now you subtract the 2 grade 12, you end up with 153,43 degrees. That is your inclination. Look at the value. It is between 90 and 180. That is your quadrant 2. And then now let's look at the allocation of marks for this. This is 2 marks, of which I think is unfair. From myself, I will give 3 for that. The first mark will be for the substitution into the inclination formula, your gradient, and the second mark will be for the reference angle, and the third mark will be for the actual angle of inclination value, of which is 153,43 degrees. And then that is the 3 marks, grade 12, that we are allocating for that particular angle. Right, and then in this case now we need to calculate the length of QR. Where is QR now? QR, we are taking the distance from here to there. And then leave again your answer inside form, grade 12. We don't want to see decimals because it is indicated that you must leave your answer with that root sign. Okay, now we are looking at the length of QR. We need coordinates of Q and R. Let's take out our coordinates first. Q is 0 and minus 4, and then the R is 6 and minus 2. So now the length is the distance. So we are looking at distance QR, and the distance formula states that the x2 minus x1 squared plus the y2 minus y1 squared. And remember, this is on your formula sheet, grade 12. Ensure that you copy it correct from your formula sheet. And then now with the substitution, this is family 1 x1 y1, this is family 2 x2 y2. And then now we are substituting that into our formula. The x2 is 6 minus x1 0 squared plus the y2 is minus 2 minus y1, it will be minus 4, and then everything squared. And then now into your calculator, straight to the answer, grade 12. Avoid simplifying in between. Therefore this will be 2 square root of 10. Leave your answer in said form. Therefore we leave our answer with that said form. So the first mark will be for the correct distance formula. Secondly, for the substitution. The third one for the final answer in said form, grade 12. So for this question will worth 3 marks as indicated there. Right. Grade 12, next activity. We are still on question number 3 and 3.4. We need the coordinates of E. Remember that it is indicated that E is the midpoint of PQ. And then now determine the coordinates of E. That means X and Y value of E there as being the middle point of PQ. Okay, so now we need coordinates of P, of which is -2 and 2. From the statement there, E is the midpoint of PQ. That is why we are taking coordinates of PQ. And then Q will be 0 and a -4. Okay, and then if you look at E there, E is the middle point of that, right? So now the midpoint of PQ is equal to the formula. Do you still remember grade 12 is x2 plus, not minus, ne? x1, x2 plus x1 over 2, coordinating with y2 plus y1 over 2. And then now we have x1, y1, family 2 is x2, y2. Substitution into the correct formula, x2 0 plus x1. So it will be plus minus, therefore it will be -2. And then over 2. And then y2 is -4 plus y1 plus 2 over 2. So 0 minus 2 is a -2 over 2. And then with a -4 plus 2 is a -2 over 2. So the coordinates of E, of which is the midpoint of PQ, is -1 and -1. Let's refer to the diagram and check, is it possible for this to be both negative? Yes, Ex is negative and the Y is also negative. So these are perfect coordinates of point E. So mark allocation 2 marks. It's 1 for the substitution of the values into the correct midpoint formula. And then the second mark will be for the correct coordinate X and Y being a -1 and -1. Next activity 3.5, grade 12. We need the equation of SR. SR is this line here. If SR is parallel to PQ, do you still remember those conditions? If it's a parallelogram, therefore the two sides are equal. And this is worth 4 marks, grade 12. Let me give you 5 minutes to do this activity on your own and check how far can you go with this. Please analyze before you start answering. Your 5 minutes starts now. Okay, grade 12. So let's see how far did it go. Remember WhatsApp number 079-454-9535. You are more than welcome to send your clarity seeking questions to that particular number. Right, in this case, we were looking at the equation of SR, of which SR is parallel to PQ. That is our key information given to us. Now, when you look at SR and PQ, if they say these lines are parallel, that means the gradient of those two lines are exactly the same. So remember, grade 12, we are looking at the equation of this line here. Now, if you try to find the gradient of this, we have a challenge because the value of y there is not given to us. Okay, so now to find the gradient of this particular line that we are looking for the equation of, we need to find the gradient of this line first, so that we can use that gradient for this particular line. Since the lines are perpendicular, therefore the gradients are exactly equal. Okay, now after analyzing, you can see that your starting point will be from calculating the PQ. So that means we are going to look at the gradient of PQ now. We need coordinates of P, which is -2 and 2, and the coordinates of Q, of which is 0 and -4. And then we will be calculating the gradient of PQ, of which will be y2 minus y1 over x2 minus x1. And then this is family x1, y1, and family x2, y2. So y2 is -4, minus from the formula, and then y1 is 2 over the x2 is 0, the minus from the formula, and then this is -2 from -2 for x1. And then now into your calculator, grade 12, say straight to the answer, we end up with a gradient being a -3. Is this correct to have a negative gradient for PQ? Let's check. Yes, PQ is a decreasing function. Therefore, the gradient of this line must be negative because the line is decreasing. Yes, this is correct to be negative. And then now, since the lines are parallel, therefore, M of SR is equal to the M of PQ. Reason is SR is parallel to PQ. That is why we can conclude that. And then now that means this will also be a -3. M of SR will also be -3. Happy grade 12, we have a gradient of that line. Remember, to find the equation of a straight line, you need a gradient and a point. So we have a gradient and we have point R, which is the point that lies on that particular line with coordinates 6 and -2. We are avoiding S because it is having an unknown M. So now if a learner decides to use 1 mx plus c, so we'll have this point as x and y here. So y will be -2, the gradient -3, and the value of x 6 plus c, of which is -2, 6, 12, 18 minus 18 plus c, and then c will be equal to 18 minus 18 to the left hand side. It will be positive 18. Positive 18 minus 2, that will be 16. So the real equation now, we are substituting into this equation y equal to mx plus c. We will substitute the m and c and leave y, and then m is -3, and then x plus the value of c, which is 16. Therefore, that is the correct equation of that particular line. As you can see, it is going up there. It will cut the y-axis somewhere at 16, hence we are having c being 16 there. So if another learner decides to use the other equation, of which is y minus y1 equal to m into x minus x1, this is supposed to be the same answer, but that learner will regard the coordinate as being x1 and y1. So it will be y minus y1, which is minus 2, okay, and the gradient same is minus 3 into x minus from the formula, and then x1 is 6 there. Okay, so this will be y, a negative, times a negative is a positive 2, and then we are distributing minus 3 into the bracket there. That will be minus 3x, minus 3 times minus 6, that is positive 6, 12, 18. And then we have y here. We are transposing positive 2 to 18 there. This will remain minus 3x, and then 18 minus 2 will be plus 16. Can you see, grade 12? We end up with exactly the same formula, whether you use any of the two equations there. It's up to you which one is the simplest way for you. Now let's look at the mark allocation. The first mark will be for the gradient, calculating the gradient of PQ, substitution, and the gradient. The third mark will be for predicting that the gradients will be equal, and you substituted that gradient with the coordinates into the correct formula, and then for the final equation. So this is worth 4 marks, grade 12. I hope you manage to get that 4 marks. Some examiners may give up to 5 marks for that problem, grade 12. And then now let's move on to 3.6. In the diagram, we are still using the same diagram, and then now we need to calculate the value of m there. Remember, we have an equation of this line already. We have calculated that the equation of line SR is y equal to minus 3x plus 16 from the previous question 3.5. Now, if you want to find the value of m, we are going to take this point S there and substitute as x and y. So our y will be m, and the x value will be 4, and then plus 16 there. And then 4, 8, 12 minus 12 plus 16. Therefore, the value of m will be equal to 16 minus 12, of which is the 4 there. So m is equal to 4. Therefore, the coordinate of S will be 4 and 4. Happy, grade 12? As easy as that. And then now moving on. Show that triangle PQR. Triangle PQR is a right angle triangle. If they say it's a right angle triangle, they say to you, prove that there's a 90 degrees angle here. We need to prove that there's a 90 here. And then now, grade 12, how do you prove angles being 90? To be perpendicular here, that means now the gradient of the two, the m of PQ, when you multiply it with the m of QR, they must give you a -1. If that is the case, therefore, this is 90 degrees. Okay, so we need to prove that the product of this will be able to give us a -1. We do not conclude that, grade 12 initially. You need to show us that it is true that the gradient is -1. Let's start now. Do we have the gradient of PQ? Yes, we have calculated it on question number, on our previous questions there. Let me check. We have calculated the gradient of PQ being a -3, as we were finding the equation of the SR, grade 12. We have calculated that m of PQ from the previous activity, that it is a -3, right? And then from that one, now we need to calculate the gradient of QR now and check what we will get from that. M of QR is equal to y2 minus y1 over x2 minus x1. And then we are depending on Q, 0n minus 4, and the R, 6n minus 2. And then this will serve as our x1, y1, and then x2, y2 there. And then what is y2? Minus 2 minus 4 for y1 over x2 is 6 minus 0. And then if you calculate this, well, grade 12, you end up with the gradient being 1 over 3 for QR. Now we want to test this condition, right? Let's check the product of the two. We are having M of PQ multiplied by M of QR. We are testing grade 12. Will it give us minus 1? M of PQ is minus 3 multiplied by M of QR, which is 1 over 3. And then if we multiply the two, we end up with minus 1. Therefore, the gradient of MPQR and gradient of QR, they are giving us a product of -1. Therefore, line PQ is perpendicular to line QR. If these two lines are perpendicular to each other, therefore, triangle PQR is a right angle triangle. Okay, so now let's look at the mark allocation for this one. The first mark is for the gradient calculated being correctly of QR, that is 1/3. And then the second mark is for showing us that the product of the two is giving us a -1 grade 12. The mistake that you are doing grade 12 is to start by telling us it is true that it is -1. No, you need to check, is it true that the product will be -1? Remember, in this case is for you to test, is it true that it will give you a -1? You cannot conclude automatically that the answer will be a -1. Show us that it will be -1. Okay, and then now move on to the next activity. And then in this one now, no diagram, you are only given, all the given information is in our statement now. So it says M with coordinate 4 and 4, N with coordinate P and 3, and T be -1 and Q. And then our points in a Cartesian plane. If these coordinates are points in a Cartesian plane, calculate the value of P if the gradient of Mn is equal to half. So grade 12, we are just making a prediction. We don't know the actual diagram for this, but we know we are having M in quadrant 1. Why? Because M is +4 and the +4. And then we are having point N. We don't know whether N is in quadrant because Y is positive here. It can either be in quadrant 2 or in quadrant 1. We don't know the actual X value, whether it's negative or positive. And then R is 1 and 1. So R is in quadrant 1 with coordinate 1 and 1 there. That is our R. And then T is -1 and Q. We don't know Q whether is in a positive or negative. Can you see? It's not that easy to predict this diagram because now we have unknowns there. Right, but they all fall in a Cartesian plane, and they say calculate the value of P given the condition that the gradient of Mn is equal to a half. That is your starting point. So now that means we are relying on M and N. M is 4 and 4, and then N is P and 3. Why Mn? So that you can find that P now. Okay, the P that lies on N. So now the gradient of Mn, M of Mn, gradient of Mn, it's y2 minus y1 over x2 minus x1. Why? Because we are given that gradient. So this will be x1, y1. Same method, grade 12, x2, y2. So now the m of mn is given, that is equal to half. Gradient of mn is half, and the y2 is equals to 3 minus the y1, which is 4, over x2 p minus x1, 4. Look at that. Can you see now your unknown is only p there? So we are having half equal to 3 minus 4 is minus 1 over p minus 4. And then you are having a fraction, equal sign in between and a fraction on the right hand side, so we can just cross multiply there. So when we cross multiply, we end up with p minus 4 times 1, which is p minus 4 on the left hand side. Right hand side is 2 times minus 1, which is minus 2. Therefore p is equal to minus 2 plus 4, of which p is equals to 2 grade 12. Can you see now? P actual coordinates of p is 2 and 3. That means it also lie on the first quadrant because both x and y values are positive. So that is how you calculate the unknowns from the given information. Okay, and then now the next activity. The value of q if Rm is perpendicular to MT. Let's try grade 12 within few minutes. Let me give you 3 minutes to work out that one. And then now we will be concluding our day with that activity. I hope you will be able to get a 4 out of 4 grade 12s just for today. There were 3 minutes starts now. Okay, grade 12, let's see now how did it go. Right, we are still having the M coordinate 4 and 4, the N coordinate, which is now 2 and 3 as we have calculated, and then the R is 1 and 1, the T is minus 1 and Q, and those are the points on our Cartesian plane. And then in this case we have to calculate the value of Q if RM is now perpendicular to MT. Can you see grade 12 here? We are relying on what? On the gradient of RM and the gradient of MT. So we need coordinates of R because R is part of our points then. And then now we need coordinates of M since M is there, which is 4 and 4. And then we need coordinates of T, of which is minus 1, and Q. And this point will lead us to the calculation of Q then. So now where do we start? We start from what is given to you. What is given here is that RM is perpendicular to MT. Do you still remember perpendicular lines? The gradient's product is equal to minus 1. So that simply means the M of RM multiplied by the gradient of MT is equals to a negative 1. Gradient of RM multiplied by gradient of MT is equal to negative 1. Why are we concluding that we are saying is negative 1? Because the two lines are perpendicular. It is given to us that they are perpendicular. The minute is given they are perpendicular, they are also telling us that the gradient is, the product of the gradients is equal to negative 1. That is why I am using that already. And then now let's look at M of RM. RM, we are referring to this 2 here. That will be y2 minus y1 of that. So that is y2 4 minus 1 over x2 4 minus 1 again. And then multiply by the gradient of MT. MT, we are referring to M and T there. And the y2 is Q minus y1, which is 4, over the x1 is minus 1 minus the x2, which is 4. And then this is still equals to a negative 1 grade 12. That is your starting point. The substitution part must be perfect. Can you see now after substituting you have only one unknown, of which is Q. And then now we have 4 minus 1, which is 3, and the 4 minus 1, 3 there. Multiply by Q minus 4 over minus 1 minus 4, it's minus 5, equals to a negative 1. And then 3 over 3, it's 1, times Q minus 4 over 5, and then equals to a negative 1. Remember, any number multiplied by 1 is that number. 2 times 1, 2. M times 1 is M. Kongwane times 1 is Kongwane. Okay, so the multiplication by 1 is the same identity. So if we had multiplied this part with 1, we will end up with still Q minus 4 over 5, of which is equal to negative 1. And then remember, this is over 1. We are crossing this to that side. And then this will remain Q minus 4 because we are multiplying with the 1. And then 5 times negative 1 is negative 5. So our Q value will be minus 5. And then we take 4 to this side, it will be positive 4. And then the Q value, grade 12, will be a negative 1. So that means now coordinates, actual coordinates of T is minus 1 and a minus 1, grade 12. Okay, and then this takes us to the end of today's lesson. And then this lesson, grade 12, was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Till we meet again next time. Bye.